Okay, so I think we're going to try to get 2 problems done. If we don't get them both done, I'll have another one taped for you guys if you want the other example. I don't know if you really need it. They seem to catch on pretty fast this morning. So, you're going to be doing this 2 ways, right? One way is using Python, and the other way is using your summation shortcut formulas. So, if you look, Rachel showed us this nice link right here. And this has a bunch more summation shortcut formulas. You don't need to know most of these except for the first 2. So let's write down the ones we should know, the ones that could come up on one of my quizzes, yeah? The ones that you needed for that last quiz, for instance. So let's write down the ones we should know.
I think the following students to the Administrative Office: Joshua Bird, Peyton Camper, Alexis Cortez, Alyssa Griffith, Dalton Hicken, and Ryan Kohler.
Okay, I think we knew those first 3. We've been working with those for a while. So if you're just adding up 9 n times, how do you do that? It's 9 plus 9 plus 9 plus 9. That should not be something you need to memorize. It's just 9 times n. Okay, so that was the simplest one. Then we had the one for Gauss, the one that I had the story for. That's if you're going 1 plus 2 plus 3 plus 4 plus 5 to wherever this says to stop, wherever the end index says to stop. How's that go? You use the top index, and whatever this is, right? It doesn't have to be n. It could be k, it could be I, it could be a number. You use the top index, and that's what goes here, and it's all over 2. Great, okay. Then we had I squared. I know this one's definitely on the next quiz. So use n plus 1, just like Gauss, right? It's almost identical. And then there's 2n plus 1, and it's not over 2, it's over 6. So there's a whole bunch more shortcuts. Those are the 3 main ones you need to know. The one that I thought was nice to know, that you'd need in like basic college algebra class, let alone something like calculus, would be the one for a geometric sequence. Okay? So if the sequence looks geometric, in other words, if it has like a first term and then some r to the I minus 1 from 1 to n, like that problem that was just on our quiz a second ago. That's the toughest one, I think. That one is A1, and then you've got some big parentheses.
1 minus r.
Use the top index again. Or 1 minus r. So I don't know if that one I'll even put on the second quiz, but it might be there, okay? I don't think we're going to use that one today either. But those are the only 4 that could possibly show up on a quiz now, or probably even next year as well. Does that make sense? So, there you go. 4 in calculus thing. There's no more. So, there are, of course, a lot more, but you don't need to remember them. There's this nice little summation shortcut formulas thing. Ben, can you press the button? Can you click that summation shortcut thing? So for some of the problems that you guys are going to do, you're going to need more. So you guys can see Gauss's as the one on top, then there's the squared one, and then there's a whole bunch more, and they get bigger the higher the power goes. That's just the way that nature works. So you can use these as needed. So we'll do at least one example where we need to do one. So I thought first we'd talk a little bit about how this is going to work in Python. Okay, I'm going to pause my thing. Before I actually open Cold Sculptor, I was going to give you guys a couple notes. You can put these in your notes or on the back of your quiz, or wherever you want to keep them. I'd put them in your notes so that everything's all in one spot. So I think we're going to need to do a few things in Python. So these are Python ideas that are necessary for, let's say, executing sums. So I broke this down into 4 steps. I think you guys will see that these 4 steps kind of make sense the way we're going to write our program. There's, of course, other ways to do it. We're going to do it in 4 steps. So the first step is we need to tell it how far we're going to go and where we're going to start and where we're going to stop. So we need to create a list, like a sequence, right? Create a list of indices that tell us where to start and stop. So I guess you can put that if you want. Start and stop. So that's what we're going to need to have Python do first, is create that list and give it a name. We can kind of name it whatever we like. The next thing we need to do is use a loop. So I'm going to say employ a loop. There's different kinds of loops. One of the most common kinds of loops in programming is called a for loop. So we're going to employ a loop to do, using a word we learned yesterday in that film, and I think we've seen a couple times. We're going to use it to iterate over the list that we made. So the list of indices. That means we're going to have the loop do something for everything in that list. Okay? Then we've got to say, well, what are we doing? So let's do the one that was on your quiz first. So I think the one that was on your quiz, at the extra credit, what was it? Didn't it say go to like 300? Go from n equals 1 to 300. What were we doing? 14?
14n squared minus 2n plus 11.
Yeah, so I wanted to start by doing that example. We'll have Python do that instead of the shortcuts, because you guys have the key, so you can see how to do it with the shortcuts, right? So we'll check and see if we get the same answer as Python did. So what we need to do is do this in like 2 parts. So we've got the list, the 1 to 300. We've got the structure that the thing's going to use to go from 1 to 300. Then we need to tell it what to do. Well, what to do is right here. So we need to use each index to create a term in our sequence. In other words, we need to tell it to do what the sum says to do. This stuff. This stuff is what we have in this case. We need to tell it for each index, go 14 times the index squared, then subtract 2 times the index, then add 11. Does that make sense? And then finally, I mean, what are we supposed to do? Are we just supposed to have a list of things, or are we supposed to add those things together? This symbol right here says add the things together. So we need to sum up or add up all of the terms that we made here. So I think those are the 4 basic steps you guys are going to see me use when I create this program. Okay? Here's your password.
Oh, sorry.
No, I'm sorry. Thank you. Do you guys have the answer just from the summation shortcuts from the quiz? Who got it right? I know a couple people in here got it right. What was it? What was the answer? You guys have it? Or can somebody flip the key and find the answer at the bottom of that key, please?
It's 126,543,000.
700. 700?
Yeah, 543,000.
Just go 126.
543,700.
Ah, okay, thank you. Okay, so that's the number we're looking for Python to do, so that it doesn't have to do shortcut formulas. We're just going to create a program that does this, and it's going to do it brute force and do every single thing and add it all up like a human being would ever want to do. Okay? Okay, so let's derive that with the summation shortcut formulas. So here's what you would have had to put to get the full extra credit score on the first quiz. So first we're going to distribute the sum. So, and I'm also going to pull out the constants in front of the sum, just like we talked about last week. So there we go. Then I'm going to distribute the sum to the next term and pull out the 2. And now I'm going to distribute the sum also to the 11. Now I'm going to add all my indices. There we go. So now it's time to apply our summation shortcuts. So I think we have Gauss's shortcut that we're going to have to apply to the n, where it's just 1 plus 2 plus 3 plus 4, etc. Here we have the easiest one, where it's just 11 plus 11 300 times. So that's going to be 11 times 300 right there. Here we'll use Gauss. We've got a 2 out in front of Gauss, though. So for Gauss, remember the way you use it is you go the top index times the top index plus 1. Usually we say n times n plus 1, but I don't want to use too many n's here to confuse you. And then you have to divide by 2 when you're using that shortcut. So then the other shortcut we have to use is for the squared term. That's kind of the biggest one that you're responsible for remembering. So I'm going to back up a little bit and say 14 times that shortcut. So if you remember, for the squared shortcut, you have to divide by 6. You use the top index times the top index plus 1 times 2 times the top index plus 1, 2n plus 1. So that's going to be 600 plus 1. Okay, so there we go. Now all we've got to do is enter this in our calculator and have it do it for us. So first I'd search to see if you have any shortcuts that you can kind of make easier for your calculator work. So here I see that the 2's cancel. I don't know if there's too much else that would cancel here. Yeah, so I think I'm just going to do the rest. I mean, 14 over 6 you could reduce by 2 or something if you like, but I'm just going to go to my calculator from here. So we'll see if our answer checks out what I wrote down just a second ago. So in my calculator, let's see, I have 14 times, I'm going to use an alpha y equals here to get a nice fraction. Go 300 times 301 times 601 all over 6. Okay, we canceled the 2's, we've just got a subtraction of 300 times 301. There we go. Now we can add 11 times 300. All right, so there is what we have for our answer for this problem. So hopefully we get the same answer when we look at the brute force approach using Python. Okay, so if you watch the video, like, you'll see that I do both of these with summation shortcuts. I should do both of them on the computer. They're both totally on the video. So this is the other one we're going to code up. Maybe we'll even just start with this one. So let's do it with summation shortcuts. Neither one of these shortcuts do we have to know. Like, they're not going to show up on your quiz, but they're in this little link, okay? So I think we need the third power one and also the fifth power one. So first, remember, you distribute the sum. So we're going to say, hey, this is equal to the sum on the third power from 1 to 50 minus 3, pull the 3 outside, the fifth power from 1 to 50. And then we use the shortcuts for third and fifth power. So how's that going to go? You can also write this as the sum of the first 50 terms. I think we've seen that notation sometimes too. So we'll say the sum of the first 50 terms. Let's use these shortcuts that are right here. So there's the third power one, right there, if you guys can see it. Okay. So it says, first take the top index and do what with it? Square it. So we're going to go 50 squared. And then we're going to have times top index plus 1, 51 squared. And this one's all over 4. Okay. And then we've got to do minus 3. And we've got to use the fifth power one, which is bigger. So I'm going to go down here and say the top index is again up there. 50. So I'm going to go 50 squared.
Times 2 times 50 squared.
2 times 50 squared.
Yeah. Plus 2 times 50 minus 1.
2 times 50 is just 100, so I'm going to write down 100 there. You do it how you want. This is all going to be over 12, right? I'm missing something still, though.
Yeah,
one more thing.
The n plus 1
The n plus 1 I haven't done yet. So n plus 1
would be
51 squared. So that's what we need right there for the sum of the first 50 terms. So could somebody in their calculator compute that? Let's see what we get. I'm going to compute it as well.
It's kitty kitty boo pal. It was easy to.
Okay, so the other problem that we wanted to do both ways was we wanted to compute the sum of the first 50 terms when we went I cubed minus 3i to the fifth. So a second ago we split that up by distributing the sum and pulling out the 3, and we applied the formula that you definitely don't need to know for your quiz for the third power. and for the 5th power, which is pretty big. I think I gave you one that had like an 8th power, so that's like the longest one you'll need to do. I think that the hope of these problems, one of them is to hopefully get you to the point where you're not intimidated by lots of large numerical calculations. We have calculators and computers to really help us with those. So I'm going to enter this problem in the calculator and show you how I would do that. So we should, I think, first look, though, before I just jump right to the calculator, see if there's anything that can simplify nice. So I don't know. I don't think there's much you can do with that. I mean, you can start to do some things in your head, like 50 squared is 2,500. I did one over here already. I guess we could put this as just plus 99, right? Let's see. 3 over 12. I'd always look right here to see if there's any cancellation. That would cancel to 1/4 instead of 3/12, but again, that's not making it so much easier to enter in the calculator, so I'm just going to do it like it is. So you can do this in parts, or you can do it all at once. I think I'm going to do it in 2 parts for the purpose of this one. So I'm going to go alpha y equals and go 50 squared minus 51 squared minus, whoops, times 51 squared all over 4. That's that number. And then I was going to do -3 times, go to my fraction, do 50 squared times, it's in parentheses, 2 times 50 squared plus 99 we said, and that's times 51 squared. That was all over 12. Let's make sure we had our 3 in there. I'm just going to go back and check, scroll over. Yes, I did have my -3 in there, so we're going to add this to this number right here. And there we go. So that's what the sum is. That's what we should have got in Python. So you want to check those digits and make sure they're identical, because they should be, or you have an error in your shortcut formula calculation, or you have an error in how you coded it in Python. Maybe you didn't go out all the way to the last index. This guy looks like it's -8 billion and something on this problem. Okay, see you next.